Up 28 or 30 or 37 or 38. 37, 38. On 37, they give you the H plus concentration, and they ask for the OH minus. What you're forgetting is, I think I have it on your notes, that's why I keep the notes handy. Yep, I have it right at the top, and you even wrote it in. KW is equal to 1.0 times 10 to the minus 14th, and that's equal to the concentration of the H plus times the OH minus. So if you know one of those, you know the other one every time. So I know you'll get this. So on 37A,
So it's KW forward.
if the H plus is 1 times 10, well, that's, let's not do A, let's do B. 37B, if H plus is 8.3 times 10 to the minus 16th, wow, okay. If this is 8.3 times 10 to the minus 16th, how would you calculate OH? Divide this, always just to answer your question, at 25 degrees Celsius. Divide this by that. So in order to get the other one, you always divide what the one you know is into 1 times 10 to the minus 14. Isn't that simple? And the answer is going to be always in moles per liter, because these are concentrations. Remember, the product of the two always has to equal this, because it's a K value for water, KW. It's valuable, because once you know this, you know this, you know pH, you know pOH, you figure it all out. Okay, kind of important. And then on 38, it's just the opposite, so once you got this, I know you're going to get it. On 38, they ask you to calculate the H plus concentration if you're given the OH minuses. So I don't think you probably need me for that now. Huh? Good, all right. Don't worry, like I said, about the 30 over 34 for now. How about 40, 41, 42? 40? Okay. 40 says, let's just do one of those. It says at 40 degrees, the value of KW, see now they're changing it to 40 degrees. KW becomes 2.92 times 10 to the minus 14. Okay, so instead of 1.0 times 10 to the minus 14, it's going to be 2.92 times 10 to the minus 14. That doesn't change anything. You still, this times this has to equal that at 40 degrees. Okay, so calculate the H plus and OH in pure water. You just take, what would you do?
Divide by whatever.
These have to be the same for pure water. What would you do to that? Take square root. Something, it's going to be something I 10 to the minus 7. I don't remember what it is, but
1.7.
1.71 times 10 to the minus 7 when you take the square root. So it's going to be the same, except they just changed the KW on you. On the AP test, they'll stick to this one. They won't mess with you. They got enough to mess with you with. Okay, so on 40, what is the pH of pure water at 40 degrees? Okay.
You have H.
What's the negative log of the H plus, right? So it's the negative log of 1.7 times 10 to the minus 7, which was your answer to A. So the pH of pure water at 40 degrees is 6 point, and I got a lot of decimals and I want to know why. Let me just check something here. Oh, okay. I'm not going to hit you real hard on this right now. I'll sort of work you into it. But the original KW they gave us was 2.92 times 10 to the minus 14. How many significant numbers is that? Right, that's 3. So what that means in pH is that tells you how many decimal places you should have. Isn't that word?
Yeah.
Yeah. So instead of it just being 6.7 for pH, it's 6.767. I'm not going to pick on you on that yet, but I thought I'd mention that.
I thought that should be 3 significant digits, because that is, but it's,
I know, it makes sense.
that's 4.
It's
That's
decimal.
3.
They go by decimal places.
That's stupid.
It's the log thing. There's logarithmic reasons. Okay.
Stupid bar.
Interesting, as the temperature of water goes up, its pH
Yeah.
goes down. So boiling water would probably
Get to.
Now you know why,
water.
now you know why boiling water burns.
Because it's acidic.
No, because it gets rid of the bases and acids so you can drink it, it burns off.
Let's go.
Okay. How about 42? You're gonna calculate again, H plus and OH, and they just give you various things, and this is where I'm trying to get you to become adept at doing this without even thinking. So if we wanna know H plus concentration in moles per liter, and OH minus concentration in moles per liter, and they give us something, we should be able to figure it out. So pH is 7.4. Okay, so this is A. If the pH is 7.40, what can we get from that?
H
Figure out
plus
the
equals-
We get the H plus, because the H plus is gonna be what, the
10 to the negative pH.
oops,
10.
10 to the negative pH. Okay, so 10 to the negative 7.40. Okay, there's a couple of ways you can do that on your calculator. You just go 10 caret negative 7.40, whammo, 3.98 times 10 to the minus 8 moles per liter. Hopefully that's right, okay. 4.0, rounded off. Or you can go second log negative 7.40 close wham. Either way works. Okay, so get used to that. Now, to get the OH now, once you know the H plus, this is 4.0 times 10 to minus, I forgot, 8 moles per liter, because it's concentration. Once we know that, then we can figure out the OH because of this, right? Just plug in the KW equation and solve for the other one. So once you know one, you always know the other one, it's just a calculation away. Okay?
All right.
Any other ones there? How about like, let's take a look at F. To give you the POH. Now, there's a couple of ways you can go about on this. If they give you the POH, okay? 9.60. Depends on how your mind works, but if you want to stick to just pH, just all I can handle is pH, then what would you do? Subtract that from 14, and away you go like we just did. Or, if your mind works a little differently, you could go, okay, I got the POH, so if I take the 10 to the negative POH, what do I get? I get the OH concentration, and then I can plug in over there and get the H plus concentration. So see how everything wraps around this equation? Really important. And that you know how to do, you know, calculate one and two another. I wish I had another day to just give you some more of those problems just to drill you on, but we don't. Any last minute questions?
So the concentration of H plus and OH minus equals 1
At 25 degrees Celsius. And then, yeah, as we found out, as the temperature goes up, so does the value, okay? And so I would assume as the temperature goes down. That's the only bummer about AP Chem versus regular Chem. Yes, you're bright and you're quicker than the average Chem student, but, you know, in chemistry, I do a lot of review, and, you know, we just go back. I mean, okay, we learned this yesterday, so let's review that, and here's the new stuff. And then the next day, okay, we learned this yesterday, and that the day before, now let's review this and go back. There's always review. In this class, there's no time. So that's why you have to do it, and that's why you have to ask questions, and you gotta stay plugged in. It's just unfortunate, but I don't know what to do about that, so. Any other questions on anything? Okay. Well, let me give you the new stuff then. Day 2. 2, 3. You'll get a slight break on Thursday because they're forcing, I get to go to a workshop. I've mentioned to them that maybe it's not necessary for me to go, but they disagree. I'm in